Hello children, we are doing class 10 science, chapter 12 electricity, important numericals 2. Two lamps, one rated 40 W at 220 V and the other 100 W at 220 V are connected in parallel to the electric supply at 220 V. 220 volt it is, V is representing volt. A part, draw a circuit diagram to show the connections. Now B part, calculate the current drawn from the electric supply. Now C part is the calculate the total energy consumed by two lamps together when they operate for 1 hour. So two lamps rated 40 W and at 220 V. So one lamp, symbolic representation of the lamp is like this. So symbolic representation lamp's power was actually 40 W. Voltage was 220 V. Was connected in parallel to another lamp. Of how much potential difference? Of 100 volt. 100 watt. WATT. W is representing watt. So 100 watt lamp. Now both of them are connected in parallel. Parallel means one below the other. To an electric supply. To the electric supply at 220 V. So potential difference, the battery's voltage. Battery's voltage will be, not batteries, the supply voltage actually, will be 220 V. If you want to provide the key, you can provide. Because we are completing the full circuit. Current I will flow through the circuit. Now they told you to calculate, draw a circuit diagram. You completed the circuit diagram showing the connections. Positive, negative. If you want to add the voltmeter will connect it across the two lamps. And meter is the means ammeter will be connected in series. Now here we completed the circuit diagram. This is the circuit diagram. The circuit diagram, these are the bulbs. And this one is the battery. Now calculate the total energy consumed by calculate the total current drawn from the electric supply. For drawing the current from the electric supply, we'll take two cases, power P1 and P2. So two cases I'll take, bulb 1 and bulb 2. In the bulb 1, the power, the bulb P1 equal to 40 W. The power of the bulb P1 equal to 40 W. Now power of the bulb B2 or is bulb 1 is bulb 2. Now here power P2 is equal to how much? 100 W. 100 watt it is, 100 watt. WATT. And it was connected in parallel to a 220 V supply. Potential difference. Potential difference V1 to 220 V. It's same only for both of them. If you want to write V1 or V is enough. Because in parallel connection, potential difference is same actually. In parallel connection, for both the bulbs, potential difference remains same. Now potential difference V2 or V. V1 equal to V equal to 220, I'll write. So here in the other case, potential difference V is, second V is representing the volt. Now potential difference V2. To V equal to 220 V. Now you want to find out the current I1. Current I1. You want to find out. So current I2. Also you want to find out. There are three formulas relating power. Power actually. Three formulas are there for power. Three formulas are One is P equal to VI. Next one is V squared by R and I squared R. These three formulas are where R is representing the resistance, V is the potential difference, I is the current. We'll use the formula P equal to VI because I you want to find out P1 and V1 and you know. So we'll write P1 equal to V into I1. You want to find out I1, leave that one there, take V to the denominator. So I1 equal to P1 by V. So P1 is 40 divided by V is 220. With 0 and 0 will be cancelled, 2 stable, 2 divided by 11. Unit of current is ampere. Now in the second column again we'll do. In the second column you want to find out the current I2. Write on the next line. So it will be I1, therefore I1 equal to, so here 0 and 0, 2 by 11 ampere. Now current I2. Current I2 again will do. Current I2. I2 already current we wrote. So I2 equal to P2 by V. P2 by V. P2 is 100 by V is 220. 0 and 0 will be cancelled. 2 5s are 10. 5 by 11 ampere. So you got the current I2 also. It is 5 by 11 ampere. Now you got the current I1 and I2. What they told you to find out, calculate the current drawn from the electric supply. So total current I you want to find out. Total current I, it will get divided into I1 and I2 and it will flow through two bulbs. Now total current I is the sum of I1 and I2. So total current I equal to I1 plus I2. So I1 is 2 by 11 plus I2 is 5 by 11. The denominators are same, you can add the numerator. So it will be 2 plus 5 by 11, that is I equal to 7 by 11. With 11 stable you can divide, so 7 you will take inside and 11 outside. So it will be 11 into 0 is 0. Decimal point in the question as well as in the answer. Now next 7 and then 0 will write down 70. 11 into 6 is 66. Remainder is 4. Next 0 down 40. 11 into 3, 33. It will continue. Now again it will be 7. Same question was repeated. So you will write 0.63 unit of current, otherwise 636. It will continue like that. So it will be 63, I'll just write. So which is equal to approximately equal to 0. When the third place is 4 or 5 or more than 5, add 1 to the second place. So 0.64. Therefore total current I equal to, this is the total current I. Total current I equal to 0.64. Unit of current is ampere. Now you got the total current. Now C part. So A part we completed. This was the B part. Now C part is the C part they told you. Calculate the total energy consumed by 2 lamps when they operate for 1 hour. So for the C part, I am writing once more power P1. Power P1 equal to 40 W. 40 W. Either we can change this one to kilowatt at first or at last we can do. I'll change it to kilowatt. 40 divided by 1000. It was watt actually. So when you will do 40 by 1000 kilowatt, it will cancel. I'll write that remaining on the next side. So it will be equal to 0 and 0 will be cancelled, 0.04. That is 40 by 1000. Like that also you can keep. I'll write its continuation here. Its continuation will be power P1. For P1 equal to 0 and 0 will be cancelled. 4 by 100 you will get. 4 by 100 I'll move the decimal point by 2 places. So when you move the decimal point by 2 places, it will become 0.04. What is the unit? Kilowatt. Now you change into kilowatt. because you need the energy consumed. We'll write in kilowatt hour. Time taken was 1 hour. Time t equal to 1 hour. So energy consumed E1. Energy consumed by which thing? By one bulb. Bulb B1. Bulb 1 is enough. Bulb 1. Energy consumed by bulb 1 will be equal to energy E1 equal to power into time. Because standard formula for power in terms of energy is power equal to energy by time. Write the reason because power equal to energy by time. So here in this one, power E1 equal to energy divided by power you got 0.04. Time is 1 hour. Time is 1 hour. So here E1 equal to P1 is 0.04 into 1 hour. So it will be equal to 0.04 kilowatt hour. It was the energy consumed E1. Now you want to find out in the same way for the power P2. Power P2 equal to how much? 100 W. Time was again, so we'll change it into kilowatt. Watt will not use, so we'll change 100 to kilowatt. So 100 by 1000 kW, kilowatt. kW means kilowatt. I will cancel 2 zeros in the numerator and in the denominator. So I'll get P2 equal to 1 by 10. 1 by 10 you will get kW. Now when you move the decimal point will move by 1 place towards from right to left. So it will be 0.1 kW. That much kilowatt. Power P2 or say what? Time T1 is 1 hour. Time T equal to 1 hour. Same time was used. So here energy consumed by bulb 2. So energy consumed by bulb 2. That will be equal to E2 equal to, previous case P1 into T. E2 equal to P2 into T. P2 is how much? 0.1. For E2 equal to 0.1 into time is 1 hour into 1 equal to 0.1 kilowatt hour. Got the energy E2. Now you want to find out the total energy consumed. Now we in this one now. Total energy consumed equal to E1 plus E2. In 1 hour they told. That was equal to E equal to E1 plus E2. So it will be equal to 0.04 plus 0.1. So when you add 0.04 and 0.1, you'll get 0.14. Total energy consumed. Energy consumed unit is kilowatt hour because kilowatt hour was the energy consumed. So it will be kilowatt hour. That is the answer. Okay. And now we'll go to question number 3.